Good evening. Welcome to the first session of Eyes on AI, an exclusive guidance to artificial intelligence organized by IET on campus, University of Peradeniya. When you hear the words artificial intelligence, it still sounds very futuristic, isn't it? But in reality, most of the applications we are using every day has an AI component. Be it a music recommender system like iTunes or social media application like Facebook, Netflix, Google Maps, or even Uber. All of these applications are powered with AI. So I don't think I'm wrong if I say AI is not in the future, it's already here. Therefore, to survive in a world full of artificial intelligence, the first step is to identify what it is. Don't worry, we guarantee you that by the end of this session, you will gain a thorough knowledge about AI, machine learning, and deep learning, as well as the mathematical background of artificial neural networks. The guest speaker of the event is Mr. Sahanaka Veeraratna, a graduate of Faculty of Engineering of University of Peradeniya, who is currently working as an application engineer in Synopsys. Mr. Veeraratna is an AI and machine learning enthusiast who has machine learning and deep learning based project experience for over 2 years. He has also conducted around 15 machine learning related projects. Before starting the session, I have a quick announcement to make. We will be putting a feedback form towards the end of the session in the Zoom chat as well as in the Facebook comment section. Make sure to fill it because only those who fill it will be receiving the certificate of participation. And make sure to provide the name you want in your certificate in this feedback form. Without further ado, I now cordially invite Mr. Veeraratna to take over this session.
Hello. I think you can hear me.
Yes, we can hear you.
Yeah, thank you. So still the participant number is rising, and I would like to ask first that before we start the session, most of the people contacted me and they asked me to do this session in Sinhala language, but in order to do such thing, I think we need to get the acceptance from all the participants. So can you all understand Sinhala language, or is it? I don't know if there is any Tamil people here who don't know Sinhala language. So if it is a case, please raise your hand. Sorry, please use the chat button and tell me your preference. If it is okay to do it in Sinhala. So what do you think? Okay, I got one confirmation to do it in Sinhala. So is there anyone who cannot understand Sinhala?
Yes, sir.
Yeah, right. So we will have to conduct the session in English, right? So let me share my screen. Can you see my screen? It says Introduction to AI and Deep Learning.
Yes, sir. You can.
Yeah, thank you. So let's begin our session. So time is 5:75. Yeah, we can start now. So this will be a 2-day session. This will be a 2-day workshop, and today what I have planned to do is to give you the basics of AI and deep learning, and tell you the give you an idea about the mathematical background that we run around in these neural networks and deep learning stuff. And tomorrow, what I am going to do is to build an image classifier. Actually, what I have planned is to build a deep learning model which can be used to identify and differentiate cats and dogs. So our target is to give you the knowledge to build your own image classifiers. I think that it will be a great opportunity to you guys. If you can start with such a project, then it will take you in this machine learning journey, because that is how I actually started my AI journey 2 years ago when I am studying in my third year in University of Peradeniya. So as you guys know, I have done around 15 or 16 machine learning projects so far. So that is because I have become a machine learning enthusiast. So I hope this session will make you guys know about what you can do using this AI and deep learning stuff. So let me begin the session. Actually, I am assuming that you guys do not know anything about AI and deep learning. So I will start from the very bottom. So first of all, in order to conduct this session, this is about deep learning and machine learning, but we have to have a clear idea about all these three things. What is AI, what is machine learning, and what is deep learning? I know most of the guys who are very beginners to this AI field will think that these three are some same words which have the same meaning, but it is not the same, right? When I am doing my session, if you guys cannot hear me, or if you guys have any problem, please ask me. Or if I am going very fast, then please give me a feedback so I can slow my session. So first of all, what is AI? And in this area, what I feel is you don't need to have the big definitions to understand this whole AI and ML things. You just have to have a clear idea what is AI and what we are doing here. If you have not such an idea about these three things, then I think that by keeping the definitions in your mind will not make any effect. So what is AI? Actually, in what I feel is AI is something. AI is anything that can be, AI can be considered as anything which can be used to do human stuff, right? That is one simple explanation of AI. If we build an algorithm, if we build a machine learning model, if we build any kind of machine which can do human stuff, then I can simply put it as an AI related thing. So in order to give you the machine learning image, machine learning idea, I will give you this image. So you can see that AI is the big set here, right? And machine learning is a subset of AI, which means in machine learning, what we do is have some coincidence, some correlation with AI, right? So since machine learning is a subset of AI, I can easily say that by using machine learning also we can do human type stuff, right? Because AI, I have interpreted AI as anything that can be that can be used to do human stuff. So likewise, since machine learning is a subset of AI, I can easily put up that by using machine learning we can imitate humans in simple words, right? But what is the difference between AI and ML? That is the big question, right? You should keep all these things in your mind, because I have not used any fancy presentation here. I am using basic words here, and I am giving the definitions, and I giving you the idea. So the difference between machine learning and AI, what would you think? In machine learning, the most important word is data. Without data, there is no machine learning, right? So let me put this into your mind by using an example. Let's say you are a father or a mother, right? And you have a 5-year-old child. But the thing is, your child is a little one and he cannot still differentiate cats and dogs. I mean, let's say if you are going to show a cat's image to him, but he cannot identify whether it is a cat or a dog. So this is a serious problem, right? But as a solution, what you guys are going to do is, let's say you are going to show 50 image of cats to him and say, okay, son, this is a cat, and this is another kind of cat, and this is another kind of cat. And son, you can see there are two little ears in this image, which is a common feature of cats. Likewise, you can help him to identify. You can train him to identify cats. Likewise, you can do the same process to dog also. You can show him, let's say, about 50 image of dogs and say, okay, son, this is dog 1, and this is dog 2, and this is also a dog, and this is a I don't know, German Shepherd dog. Likewise, you can give the basic idea. You can train him to differentiate cats and dogs by the vision, by the images that he sees, right? The thing is, those 50 images, 50 cats plus 50 dogs, it gives us 100 total images, right? The total 100 images are the data that you have used to train him to identify cats and dogs, right? So that is the same. So in machine learning also, we are doing the same scenario. We use data to train our models, to train our AI models, right? And we have and also not only the images, we are giving labels also. By labels, I mean what it is in the image, the name, cat or a dog. That is the label that I am referring here, right? So in machine learning also, there should be data. You use data to train models, to train AI models. Just consider this AI model is a black box for now. So you can you can draw your picture in the mind. So we have to give the data and train the model. And after training the model, we can use this trained black box to differentiate cats and dogs. Here as in the example, once we train our machine learning model, once we train our AI model to a certain task, then we can use our model to do such thing without any help from the user, right? As in our example. So if you, as I said, you have shown 100 images to your son, and after a week, he will able to identify and differentiate cats and dogs by himself. You don't need to help him. Likewise, we are going to train machine learning models artificially to do the task that we are intended to, right? And the machine learning is driven by data. You have to use lots of data to train a machine learning model. But in the AI, sometimes there may be some algorithms which do not require data. In AI, data is not a requirement. But in machine learning, data is a complement, is a compulsory thing. You should have data. I think that now you have some idea about AI and ML and how to differentiate machine learning from AI. Okay, now we dig into deep learning. DL stands for deep learning, and ML stands for machine learning. I think you got the idea. So as you see this image, deep learning is a subset of machine learning, which means in deep learning also we have to consider data, right? Because simply, logically we can say that since deep learning is a subset of machine learning, then deep learning also require lots of data. Actually, we can divide these machine learning algorithms by using different ways. One way is, let's say, I can divide machine learning algorithms into two parts. Let's say the first one is the deep learning algorithms, since you can see that deep learning is a subset of machine learning. And there should be non-deep learning algorithms also. Let's say, as an example, I can give you an algorithm named support vector machines. Please don't you don't need to get confused about these few fancy words. What we are focusing in this session is deep learning. That's why I'm going to give you the big picture. But if you get any confusion or about the other things, please don't make it an issue to conduct the session. What we have to know is to get the basic idea, right? So as I said, I can basically divide machine learning algorithms into two parts: deep learning algorithms and non-deep learning algorithms, right? In non-deep learning algorithms, in deep learning algorithms, what we do is we are going to build a human type of brain in the computer. You know, human brains have been the creation of neurons, right? In your brain, there are millions and billions of new neurons that can be seen. So neurons are a little. Just consider that neuron is a little component which can process something. Let's get the idea in that way, right? So we are going to build a human brain in our computer in deep learning. But in non-deep learning algorithms, we are not going to do such tasks. I hope you get the idea. So all the neurons and neural networks words coming in the deep learning stuff, right? So in deep learning, what we basically do is we are going to create human brains in our computers. We are going to model neural networks, which can be seen in our brain, in the computer, in the machines. So that is how we are going to find deep learning solutions tomorrow by creating a neural network. And I hope at the end of the day, you will be able to build any image classifier by yourself also. You will gain the knowledge to do such tasks. So I think that you got the idea. What is AI, what is ML, and what is deep learning so far? So is anyone having a problem so far? I don't know. Actually, there will be a Q&A session at the end of the session also. So if there is no any question, I can go to the next slide. Yeah, I'll go. Right. The next concept that I'm going to talk here is about machine learning versus traditional programming. So what is the difference between this machine learning and traditional programming? Okay, by traditional programming, what I am telling here is, let's say you are a student in the school and your class teacher needs to build an algorithm, a simple program to classify your grades, let's say A's, B's, and C's, and W marks according to your average marks in the term test. And she will tell you, let's say your name is Saman, and the teacher will tell you, hello Saman, could you please be kind enough to build a small program to get the output, to get the grades as the output. And when I input the students average mark, so what will you do is you will start to write a program, let's say in Python or Java or any kind of a programming language that you know, and you will start to follow the if-else case, right? So if the input marks are bigger than 75, then you will type okay, if input marks are greater than 75, then put the output as A. If it lies between 65 to 75, then please respond B. Likewise, you will write a simple algorithm. So here in these kind of algorithms, we give the input to the program and we get the output that we desire, right? So that is the traditional programming. And this slide shows that in traditional programming, we give the input to the program, and the right side of the equation is output. Sorry, when you give the inputs to the program, basically you can get the output in traditional programming, as I mentioned, using this teacher-student example. But in machine learning, we give input plus output, and we get the program as the outcome. So this will be this will confuse you a little bit. Let's put it in this way. In machine learning, you can easily find two phases. Let's say two steps in machine learning, you have to follow two steps. as the first step, you have to train the machine learning model. And as the second step, you can use this trained machine learning model to predict the to get the predictions for your cases, right? So in order to train the machine learning algorithm, what you need is to give the inputs. As our previous scenario, you have to give the data plus the labels to our black box, right? So in machine learning, when you give the images of the cats and dogs and the labels, which means what is this image is containing? Is it a cat? Is it a dog? Likewise, those are the labels that I'm referring to, and that is the output here, right? When we input the images or the data that we need to train our algorithm, plus the labels that we desire to our black box, that we can get our machine learning model as the output. And once that is the training phase, and once we complete our training part, we have a good machine learning model, which I am referring here as the program, this one. And we can use this program or the machine learning model to predict in future scenarios. Let's say you are going to train a machine learning model tomorrow to identify cats and dogs. So in that scenario, inputs will be the cats and dogs images, right? The outputs will be the labels, which means the image, these images, which means is it containing cat or a dog? You have to give that to your computer. And we are trying to get our machine learning model as the output. So at the end of the day, you will be able to get a good machine learning model as the output, as in the equation. And once you have this machine learning model, in a week, let's say you are going to, I don't know, I think, let's say you are going to test your machine learning model to new images. Let's say you put a cat's image to the machine learning model, and now it will say, okay, this is a cat, right? Okay, this is a dog. Likewise, now it have the ability to give you the predictions that you desire. So that is the basic difference of the traditional programming and the machine learning. In traditional programming, what we do is we give input to the program and we get our desired output. But in machine learning, we give input and the output to algorithm. And the output from this algorithm is the machine learning model that we need, right? I think, sorry. Primash, can you see my drawings here?
Yes, I am.
Yeah, thank you. So we give these inputs and outputs to our algorithm. So let's say this is we give these two to our algorithm, and it will generate the program that we need, the machine learning model that we need. I think you got the idea. So this image will clarify your doubts. So let's define this image from the top to bottom. So we have the training data set, which means in our context, cats and dogs images, right? And we give these data to learning algorithm, and this is the algorithm that we are going to create tomorrow. So we are going to use Python as the programming language, and we are going to code this learning algorithm, right? So you don't need to worry about these two, because we have the training data set. Since we have the cats and dogs images, okay, you don't need to have those images. I have those images, so you can see, you can watch how I do. So I have this training data set now, and this learning algorithm is the code that we are going to create tomorrow using Python. So this is also okay. By using these things, we can get the trained model. Okay, now this is the thing that we need, right? And using this trained model, we can input new data to our trained model, this, and it will give our predictions. In our case, we give cats and dogs images to our code that we are going to create tomorrow, and it will generate our trained model. And once we input, let's say cat's image, it will say, okay, this is a cat. And once the image dog's images, it will say, okay, Sahanika, this is a dog, right? This is the big picture that most of the guys cannot understand in this machine learning as a beginner to the machine learning world. So I hope you all got the thing that I have said. So if there's any question, please ask. Yeah, we are good. Okay. In machine learning, actually, machine learning is a broad field. We can find many different algorithms in the machine learning world. So now now at in the early slides I have give you how we give you the idea about the AI, and we have narrowed down our problem to machine learning, and now we are digging through our machine learning journey, and we are going to focus on the deep learning stuff, since we are going to do our project in deep learning using neural networks. So I am basically trying to give you a clear idea about machine learning also. This one. So in machine learning, we can categorize machine learning algorithms in many different ways, as I previously classified as deep learning algorithms and non-deep learning algorithms. Sorry. That is one way that we can divide these machine learning algorithms. And this is another way. We can divide these algorithms as supervised learning algorithms and unsupervised learning algorithms, right? So what is supervised learning algorithms? That is the thing that you need to know. So what is unsupervised learning? You have to keep this, you have to draw these pictures in your mind to dig deep in this AI AI stuff. So what supervised learning mean is this one. To train our machine learning models, we should give both data and the labels. That is supervised learning. In unsupervised learning, we do not need to give labels. We only need the input data. I mean, we do not need to input the labels that we give for the give by the data. But and I know that this might this will confuse you guys again, because as I said earlier, to train a machine learning model, we have to input the labels also. Please don't be confused here, because it is one way that we can define machine learning. Actually, I have used supervised learning algorithms example to give you an idea about machine learning, right? In supervised learning algorithms, we have to use data and label as the input to our algorithm. But in unsupervised learning, we don't need to give labels. So we are focusing in this way. I mean, in tomorrow, we are following this path. We are using we are going to definitely use a supervised learning algorithm, right? And in supervised learning also, we can divide two parts. That is regression and classification. By the classification, what I mean is, if your problem is a classification thing, if you need to categorize your data into your data into groups, let's say you are going to, as an example, if we are going to train a machine learning model to identify cats and dogs, then what we are going to do here is we are going to basically categorize our input to a cat or a dog, right? So that is classification. Let's say that you are going to build a machine learning algorithm by yourself, machine learning model, to differentiate apples from bananas. So in that scenario, what you are going to do is you are going to show a banana to the model, and it will say, okay, this should be banana. Okay, this should be apple. Likewise, the output labels are predefined here. The groups in classification, that is actually the word classifications define that thing, right? But in regression, there is no such groups. Let's say that you are going that you have collected some temperature data throughout a year. So by using this temperature data, let's say that you are going to collect all the temperature data. Let's say you are from goal and you are going to watch your clock, and when it is 12 o'clock, you are going to record the current temperature throughout a year from January 1st to 31st of the December. So you are going to, so ultimately you will get 365 data. And that is our data set here. And what you expect is to do from this machine learning model is to predict the next year's selected date temperature. Let's say you want to get the prediction. Let's say, okay, what will be the noon temperature at 5th of January. So that temperature value of 5th of January will not be a classified value, right? It will be a continuous value. We cannot classify temperatures, no? It can be 25.6 Celsius. It can be 27.2 Celsius. Likewise, in regression, we get the continuous values as the output. Of course, we can, after getting this regression, after getting this continuous values, we can categorize them also. But here the basic difference is, in regression, we get continuous values as the output of a machine learning model. But in classification, what we get is the groups that we have predefined. I hope you have got what I'm saying, right? So we have basically defined the supervised learning algorithm stuff here, this thing. Now, what is unsupervised learning? In unsupervised learning algorithms, as I said, we do not need labels. We just give him the data. So let's say you are going to give some numbers from 1 to 100. There may be integers, there may be decimal numbers. And what you need from your machine learning model is to cluster this data. Let's say you have numbers 1, 2, sorry about my handwriting, 1, 2, 5, 97, 88, let's say about around again 3, 1, 2, 5, 5, 5, 97, 88, 3. This is your training data set. It's a very small data set which have only 6 values. So by using this data, you are going to train a clustering model, right? In unsupervised learning as an unsupervised learning method. Then what your algorithm will do is it will classify, it will try to group this, it will try to cluster out of this data set. So since there is a big, let's say it will cluster 2 clusters here. This is first cluster, this is the second cluster, and the first cluster will have 1, 2, 5, and 3. Since they are very small, since they are very closer to 0, and since these are more closer to 100, let's say they will they will cluster at another data point. So likewise, this can be considered as a clustering algorithm, right? So in unsupervised learning, we learn about clustering. Not only clustering, there can be some other models also, but to define you about these things, I'm using clustering as one of the algorithm that we can find under unsupervised learning. So I hope that you get the idea about how to differentiate supervised learning from unsupervised learning, how to differentiate regression from classification, what is clustering, and believe me, these are the basic interview questions that you will get if you go for a machine learning job or a deep learning job. This will be the basics, because they know that if you do not know about supervised learning, or if you do not know how to differentiate regression from the classification, then you do not have the guts to come here, right? And in some of the books and some of the people adds reinforcement learning as, let's say, like this here. They categorize machine learning algorithms into 3 parts: supervised learning, unsupervised learning, and reinforcement learning. But to explain you more clearly, I have delete this part, and I have given you the basic idea. And just remember that there is something called reinforcement learning also. In reinforcement learning but the thing is, reinforcement learning is a bit different from these two. In reinforcement learning, what we do is we create an agent in an environment, and we are going to give him a reward once he once he follow a favorable desire, and we are going to punish the agent if it is not the thing that we expected from our model. Likewise, it is something different from these two cases. So just keep into your mind that there is something called reinforcement learning also. And yes, enough for this slide. I think you got the idea. So now we come to the deep learning, neural networks or deep neural nets. So focus on these stuff, because deep learning is the technology that we are going to use tomorrow to build our model. In deep learning, so this is a simple neural network, right? Let's define these things first. This circle, this one, is a neuron, right? And these three is a one neural layer, and this one, these four build another layer, and these two creates another layer. So basically we can identify three different layers here. So this is the neural network that we are going to build in our computer. Now please don't get confused about the drawing. Okay, we are not going to create any circles or arrows in our computer. What I am doing here is giving you the basic concept of the deep learning stuff, right? There is in the libraries that we're going to use tomorrow, the Keras and the TensorFlow, we don't need to create these circles or arrows, right? These circles suggest it's a data point. Let's say this is a placeholder. Let's say this is a variable X, this is Y, and this is Z. So these are some. This is here. It can be a number or a decimal. Likewise, it is one thing that we can put here, and here also same. It can be a number. Likewise, please don't be confused about the drawing. This image is to show you the concept. By arrows, what I'm suggesting it. This value goes to this place, and the value here in this place goes to this place. And once you understand about this mathematical and conceptual way, the deep learning stuff, you will be able to answer any question, and it will easy and it will make your work easy, right? So first you need to identify these things. So as I said, there are three neural networks. There are three layers in the network, in this particular network. And here you can find another new neural network which has 4 layers. This is the first one, this is the second one, this is the third one, and this is the final layer. So you can identify that there are 3 kind of layers that we can find in a deep neural net. First one is the input layer, this one. And second one is the output layer, this one. And third type is the hidden layers. Actually, there can be any number of hidden layers between this input layer and the output layer. So there should be one input layer, and there can be one output layer, and there can be many hidden layers in between between these two. And if you dig deep in this deep learning stuff, we can find that there are some neural networks which have multi-input layers. So there can be another input layer likewise, like this. This is input layer 1, this is input layer 2, and some neural networks contain many output layers also. So don't think that so this is only for the beginners. Okay, you just have to keep in your mind this this image because it will give you an clear entrance to a deep learning journey. But you will have to know that there are has a bond with this neuron, right? And this arrow suggests that bond. And let's say that we have some numbers, as I said, here the placeholder is containing number 2, and this is 3, and this is 1, right? And you can and there are some numbers in these arrows also. Let's say this is 0.5, this is 1, this is 2. And when we call these values the weights, this 0.5, 1, 2, these are the weights that we can find in the neural network, right? And not only for these arrows, also there also can be, let's say this is 3, this is 4, this is 5, this is 0.8. Likewise, each and every of these arrows have some weight as the potential. So this is the basic picture of the neural networks that we are going to learn. So you just need, so the things that you just need to know is there can be there should be input layer, there should be an output layer, and there can be many hidden layers around these things. And this is what I am suggesting as a layer, and this is also a layer, and this one circle is a new neuron, and neuron can be considered as a placeholder for a value. Basically, it is keeping a value here, and these arrows have some weights around them. So those are the things that you have to get the idea out of this slide. So if you have that kind of an idea, then we can proceed further. So any of you guys having any problem with that, please ask me. I don't know if you guys sending me any messages. Please use your microphone because I don't see an option to see the messages here. Chat. Okay.
Is there a specific data type for weights, like floating points, integers?
No, we can use. Yeah, thank you, Vinod. We can. Yeah, it can be any. Sorry. Oh, sorry. My battery is low. Wait. Please give me a second. My laptop's battery is low. Yeah, I think it's all good. Yeah, sorry for the interruption. Yeah, these values can be decimals. Yeah, so don't get confused about the data type here. It can be decimals. It can be integers. Yeah, you just need to know that there is a weight, that there is a value which give the support to proceed this value from here to here. I think I answered your question.
All of them are numerical values, or
yeah. It should be numerical values. Actually, I am also learning this machine learning stuff, but I do not have any encounter any other scenarios also here. So yeah, I hope you are good. And I'm proceeding. So now I'm coming to the mathematical background here. Here, as I said, these are the input layers. Input layer. This is the hidden layer in my case, and this is the output layer. And as I said, these are the weights that is assigned to these, assigned between these layers. So as I said, I am going to process these three values. Let's say 3, 2, 3, and 5. We have this array. Let's say just think that this is an array. 2, 3, 5 as the input. So if we are, so what will be the output from this hidden layers first neuron, which means what will be the output value from here? That is what we are going to calculate. In order to calculate that, we need to use this equation. Output of a new neuron equals activation time, activation functions, and sigma wi times input. So don't get confused about this equation. This is also simple one. So let me clarify it. Wi's are these values. So here, to calculate the output of this of this particular neuron, it is bound with 3 weights, right? We have to consider all wi's here, w1, w2, and w3, because there are only 3 incoming data, right? And we have to multiply this wi value with its input, which means we have to multiply 0.2 by 2, 0.5 by 3, 0.5 by 5. And since there is sigma, we have to get the summation of all these 3 values. So, and then we are going to give it to an activation function. So in order to calculate this output of this particular neuron, let's say output equals activation function times sigma wi times input, means 0.2 times 2, 0.2 times 2 plus 0.5 plus 3, 0.5 times 3 plus 0.5 times 5. And after getting the let's this is 0.4, 1.5 plus 2.5 gives us 3, 4, 4.4. Right. Yeah. So this is the value that we are going to give to our activation function. And after going through the activation function, we get another number, and that is the output. Let's say it is 0.5. This is the output value which goes from this neuron, and we can write it as 0.5 here. So likewise, we can considering all the weights, and since we know all these values, we can calculate all the values that we can find here in these 3 cases also. And since we know all these 4 values, and consider we assume that we know the perfect weight files comes in these arrows also, we can calculate our outputs also. Likewise, we can propagate our input data to the output. I think you got the idea. Please don't worry about this activation function. I am going to explain that in the next slide. So this is how neural networks works. From input side to the output side, it flows its data in this manner by this equation.
Yeah, is there any particular reason that you are not considering the bias here?
No. Actually, we have to, we can put the bias also here to this equation. Yeah, it's also possible. Yeah, I think that. Yeah, the thing is, in neural networks, yeah, the bias values are used to some kind of giving some bias on and all those things. But yeah, you are right, and we can add the bias to the equation also. So basically,
okay.
That is how.
Okay.
Yeah, that is you are right. I have done a mistake here. But when it comes to explaining the bias, we have to consider that know about these weight files and all the biases also. So basically, when we dig deep in the neural networks, you just consider about these weights in the most of the times, but you have to consider the biases also. Bias can be considered as so those. Yeah, in future slides, I will explain the bias also. Just keep simple. Just keep your mind to this thing for now. Yeah, we can add the bias to this equation also. Yeah, right. So this is the activation function that I have explained you. So basically, there are many activation functions that we can find in machine learning stuff. So this is one sigmoid activation function, and this is softmax activation function, and this is ReLU. So there are so here I am giving you only 3 activation functions, and believe me, these 3 activation functions hold an important roles in machine learning area. You just have to keep these things in your mind, and let's try to and in our previous case, as I said, we are going to give this value to our activation function 4.4 to the activation function. Yeah, if we are going to use activation function ReLU, this one, then the 4.5, the 4.4 value is the input value here. It lies here, 4.4, and we can map it to this graph, and we can get the output. That's 4.4, right? 1, 3, 2.5. Let's say 4.5 lies here. Likewise, we can calculate the output of the ReLU function value here. So likewise, we can calculate the same thing if we for the softmax function. But if we are going to use the activation function, if we are going to use the softmax as the activation function, we can do the same thing also. So 4.4 lies around here, and it will give you the value of 1. So here in this case it's 1. Here in this case it's 4.4. These are the values that we are going to get as the output. But we have to add the bias to the equation. Let's say you are going to add 0.2 as the bias value, then we have to definitely consider it to the output also. So here I have not considered bias to the equation, so it will be completely depend on the activation function. So that is how we can get our output values and proceed our inputs to our outputs using this deep neural using this deep learning stuff, right? So again, is there any question or things that you need to clarify? Please ask.
How the gradient of the ReLU function is defined?
Yeah, in ReLU, this is actually this is 45 angle one. So all the negative values will be converged to 0, but all the positive values will have its values, which means if x is greater than 0, then it will be x. The output will be x. If x is a 0, if x is less than 0, then it will be 0. Likewise, you can yeah, it has said that. Likewise, you can generate all those things. Yeah, I hope you are good.
Yeah, thank you.
Right. The next one. So here I am going to give you the idea about training a neural network. Yes. So as I said, let's say I am going to input. So this is the data input path, data input side. And this is where we get the outputs, right? So let's say that we are going to, so we are solving a certain machine learning problem, and as the data we have we have numbers as our data, and as the first data sample, I'm going to have 1, 3, 5 as a first data sample, and as the second data sample, there will be 2, 3, 4. Likewise, there can be any 3 element array giving input to the deep learning model. And once we give 1, 3, 5 here, as I explained earlier, these values proceed to the output side, and it will generate the output values from here. Let's say that you are solving a problem. Let's take that example that you are going to do tomorrow. So you are going to build a cats and dogs classifier here, right? So so as the data, you are going to give the inputs you are going to input the images as your data. Then what you are going to get as the output is the label that you desire, right? Let's say we want to get 0 and 1 if our output is a dog, and we want to get output as 1 and here it's 0 if we need to get our output as cat, right? So this is, so the thing is, when we give our data into the computer, we cannot label them as dog or cat. We have to consider, if the dog, it means it is this array. If it's a cat, then it should be like this. We call this one-hot encoding. So likewise, if you need to classify cars, vans, buses, then for cars it will be like 0, 0, 1. Oh, sorry, 0, 0, 1. And for vans it will be like 0, 0, 1, 0. For buses it will be like 1, 0, 0. Likewise, you have to first encode your outputs to these types. Likewise, here to get the output as the dog, I am considering if I am getting 0, 1 here, then it should be a dog. And if I get 1 and 0, then it should be a cat. Likewise, I have to predefine these things first. And as I said, let's say, I hope you all know that when we input the image, what computer reads is the pixel values which brings out the image, right? So likewise, let's say we have a 2 by 2 pixel image. It's a small one. So let's say we are going to basically get 4 values to this array, and we are going to add another neuron here, and we are going to input these 4 values to this network. And let's say that though this is a very small image, it contains a dog image. So what we are going to expect from this output side is 1, 0 if we are getting a dog. We are going to expect 0, 1 for dog and 1, 0 for cat. So let's say you know that now you are inputting a dog's image, and what you get from this output side is 1, 0. But since you have input a dog's image, it truly should be 0, 1, since you have agreed to this methodology. So this is not correct, right? There should be so we call that there is a loss between the desired value and the prediction value, since these values are not same. So that is the loss that is the loss which comes under deep learning techniques. The difference, there is a difference. If there is a difference between the predicted values and the desired values, then that is the loss that we can find out from this model. And in order to calculate this loss, we use loss functions. one loss function is, let's say, the MSE, mean square, which means the it will be the difference of x1 squared plus x2 squared, mean square. No, yeah, there should be square root. So likewise, in order to calculate this loss, we can use separate loss functions like mean squared error, like categorical cross entropy. Likewise, we can use there are many loss functions in order to calculate this loss. So this is one way, and categorical cross entropy is another way, right? So using this loss function, we can calculate the loss that we generate for a certain image. We calculate losses for a certain image, and but not only for the for images for a single image, but we can calculate the sum of the losses for a batch also. By batch, what I am going to what I am suggesting is by batch is a batch of images. So let's say we are going to input 10 images at once to our deep learning model. Then it is batch number 1, and the second set of 10 images is the batch 2. Likewise, we can input not only single images but also batch versions also. So then we are going to calculate the loss function according to the batches also, batch wise. So I hope that you have got the idea now what is loss and how to calculate loss and what are the loss functions do. So once we get the loss as our output from the loss function, what we do is we try to calculate the gradient of the loss function with respect to the particular weights. So let's say this is weight 1, and we have loss. We have generated the loss using our loss function. Let's say it is L, and we are going to calculate the gradient of this loss function. To do that, we are going to use partial differentiation, daba L over daba W1. So this says the gradient of the loss function with respect to this weight, right? Likewise, there are weight 1, weight 2, weight 3, weight 4, weight 5, weight 6, weight 7, weight 8. 8 weights between these two neural layers. So we can calculate each of these gradient loss functions. Daba L over daba W1, daba L over daba W2. Likewise, we can calculate all those 8 values here. And after calculating these 8 values, let's say I am going to consider this weight. And at first, since we have input our images from this side, yeah, we can find. Yeah, we are fine. So we are going to input the data from this side, and we are going to get our loss from this side. And you will wonder, yeah, I have the images with the numbers here, but where is these weight numbers, right? W1, what is W1? What is W2? In the training phase, these W's are random values. Can be considered as some random values. But when our algorithm trains, these random values focused onto the values to focused onto some converge onto some values which will get our desired behavior from the deep learning model. So likewise, these are some basic random values when we try to initiate and run our deep learning model to train our model. Okay, so then so for this instance, I have calculated daba L over daba W1, and I am going to multiply it by alpha value. This is called the learning rate. Actually, this is if this learning rate is a big one, then we are going to find the optimum W1 value by using some big steps. If this learning rate is a very small one, then we are going to go slowly towards the converging pace. So you will be able to find these things tomorrow also. So that is learning rate. And what is backpropagation? So so consider this is a story. First, I have given data, give a 2x2 dogs image to this side, and I have calculated my loss. And for this weight, I have calculated da by W1 value, and I have multiplied it with alpha. Right? Then what I am going to do is I am going to deduct that value from the initial value W1. So what I am going to do is I am going to calculate this one, W1 minus da by W1 times alpha. And this is my next W1 value, W1 new. So likewise, I can calculate all these W1, W2, W3n for this side, right? And after that, so likewise, we can propagate these weights and the losses to this side also. So what we are doing here is we are going to propagate these weights and the gradients from back to the front. So that is back propagation. First what we do here is we have given an input to our deep learning model, and we have used loss function to calculate the loss, and then we partially differentiate that losses with respect to the weights, and then we multiply it with alpha learning rate value. And likewise, we are going to update these values, these weights slowly. So once we completely come to the front side, it gives us one complete cycle, right? So now for image one, the task is done. And then what we do is we give our second image. So let's say this is a cat. It's also 2x2 image. So what we decide is to have, since it is 1, 0, what we are going to expect to get from this side is 1, 0. If we are getting 1, 0 as the output, then there will be no loss since these are identical. But if there is any difference between the values, then definitely there should be a loss. Then we have to back propagate that to the front also. Likewise, in deep learning, in deep neural networks, what we do is we are going to do this entire process to the whole images for few times. But consider that we are not going to input a single image. We are going to input the images as batches, right? Let's say first we are going to input these around 10 images as the first batch. Likewise, we are going to train our neural network for all our data. So what is epoch? Epoch is a single run of a single data. I mean, if we are, so as I said, there may be 10 images. I assume there are 10 images in our batch. And once these 10 images go front, and then when it's come to the, from front to back, and then to back to front, then it completes my epoch number 1 after running all the batches likewise, right? So that is an epoch. So basically, we run our machine learning algorithm for let's say some I have experience of running these epochs around 50 or 60 epochs. Likewise, we can train our deep learning model. So this is how the mathematics works. But in order to calculate all these things, but in order to do your machine learning project tomorrow, you don't need to actually have this this mathematical knowledge. You just have to know the words that there are there is something called loss, and there is a function called loss function, and what is gradient of loss function. If you have a simple idea about these words and what and how it is happening, then it will be a big achievement for yourself also, because you know what you are going to do using those libraries. And I know when I learn about this deep learning stuff, at first what I thought was, oh my god, how I am going to calculate all of these values, how I am supposed to calculate all of these loss functions and then get the differentiations, and there may be I don't know, thousands of calculations, right? This same question might have in your mind also, but don't worry, now we have libraries. That is why we have installed Keras and TensorFlow in our computers, because these libraries are going to help us with these things. So actually it may be this whole process that I have said here will be a single line in Keras programming language. To train the network, it takes only one line in Python. If you are going to use Keras, of course we have to define what is the loss function of and the learning rate that we are going to use. But this whole process takes only single line of code to happen. So don't get confused about this mathematical part, because you will not be able to you will not confront all those things once you do a project. So you just have to know these things to reinforce your machine learning knowledge, because you know what is undergoing here, right? Otherwise it will be a black box to yourself. So that is why I have explained these things. If you are a complete beginner, I know that it will be very difficult to grab these things at first, but yeah, with the project, I hope you will be able to grab all these concepts. So as my last point here in these slides, I have added another thing: training, validation, and testing datasets. Actually, I have said there is something called datasets, and now I have categorized these datasets into three parts: training part, validation part, and the testing part. Right? So what is training data? And so I hope you got my idea. So let's say that you are going to collect 500 images of cats and 500 images of dogs. So you have 1,000 images as your data set, and then you need to build another 3 data sets, naming them training dataset, validation dataset, and the testing dataset. So for the training dataset, let's say we are going to put 600 images as the training datasets, and 300 images as the validation dataset, and testing and the rest, the 100 dataset, the 100 images as your testing dataset. Likewise, you need to categorize all the top dataset under 3 categories: to train, to validate, and to testing purposes. So the testing dataset is used to train your network. That is so. In the validation dataset is used to validate your dataset while you are training. That is the difference between validation dataset and the testing dataset. We use validation dataset to validate your model while you are training. But after doing the complete training process, you use the testing dataset to test your model. I hope you got the idea, and you yeah. So since time is running out, I'm going this fast. So that is basic neural networks and deep learning stuff that you need to keep in your mind. As I said, please don't think that you will not be able to cope up with our project, since this goes with a big I don't know, some complex mathematics. Actually, these are simple mathematics, but if it is okay if you do not get what I said here, because as I said, it will be a one line to do all these things, right? So then we have discussed neural networks, and after that I am going to come to this one. This is CNN, convolutional neural networks. So the thing is, so these kind of neural networks are perfectly fine if we are going to use, let's say, about few numbers. If the input data, if the input data's dimension is not that much great, that much big. As I said, I used 2 by 2 pixel images as my input here. But you know, in the practical scenarios, we will not be able to find some 2 by 2 size dogs images, right? That they will be like 50 by 50, 244 by 244, 100 times 200, like this. There may be big numbers as the pixels. So here, since we have agreed to input 2 by 2 size pixel size images, it will only give us 4 values, right? But what will happen if we get this one, 224 by 224? So it will be a big number, right? So we need to have thousands and I don't know, some millions of input neurons in order to build such an in order to handle such an task. So to help such tasks, we use convolutional neural networks. But the thing is, we use these convolutional neural networks in particularly with images. In most of the cases, we use these things with images, not all. Here, to do our problem, we are going to use a convolutional neural network problem, a neural network to solve our cats and dogs problem. So as I said, we have used 28 by 28 pixel size images as our input to the model. This is our complete model. And I hope that you can understand these parts now. This part. You know how the data propagation works, and you know how the back propagation works for this part. But this thing, this square part, is new to you. Okay, let me put this in this way. Okay, first, once we give a big image to our input, we cannot that 20. This is a big number, so we cannot use this method here, right? So what we are going to use is we use this filtering mechanism and make a small data maps out of this big image. So basically here the input size of this image was 28 times 28, and when it comes to this one, it is 7 by 7. But there are 64 times, but there are 64 feature maps in this case. But it is okay. So we are going to use this filtering mechanism from here to here. And then after we reduce our input images size, we are going to flatten these images. By flatten, I mean if we get 2 by 2 image as the output from here, then we flatten it to these four values. 1, 2, 3, 4, and here it will be like 1, 2, 3, 4. This is what I meant by flattening. And these flattened arrays are going to be the output to the neural network that we have studied already. And here we get the output. So this is what is happening in the convolutional neural network. So since you know about this part, I am going to explain this new part now. So this is it. So dig it deep the concepts. So in this part, 3 operations are going to be happen. First one is the convolution. Then one is to map the values using activation function, and then the max pooling. So let's say your input image is this. This is your input image, right? Then we can define a filter. Just say, let's just assume that it is also a small matrix having the values -0.3, 0.4, 0.8, and -0.2. So as I said, our first operation is convolution. Second one is activation. Third one is max pooling. So this is our input image, and we are going to filter out this image using this filter. So this is, as I said, we are going to assume that it is a 2x2 filter, but it can be also a 3x3 one also, which with any numbers lying in these boxes. So what is the output that we get when we filter this image by using this filter? So this is the output that we get once we do this filtering part. So what happens here is, to do the filtering part, we first use this filter and it moves from here to here. And how to calculate this value? Okay, I am going to show you that this 0.4 is going to be multiplied with minus 0.3. 0.4 times minus 0.3. This is my value number 1. And then 0.8 times 0.4. And then 0.3 times 0.8, then minus 0.7 times minus 0.2, and then this one plus this one. And we are going to, and after calculating this value, after getting the summation, we get this value, right? Then we slide our filter to the next box. That means this box. So we are going to multiply with 0.8 with minus 0.3 plus 0.1 times 0.4. Likewise, I think you got the idea. We can calculate this one, and then this box, and then this box, and then this box. Likewise, we can find all these 16 values. This is the convolution operation if we are going to use stride as 1. Stride means the number of boxes that you are going to move here. So at first we were here, then we were here. So you have moved one box to right. That is the value that we are showing here, right? So after we get our feature image, then we are going to use our activation part. So that is basically we are going to apply ReLU function to all of these values. So as I explained you earlier, we will get here we will get 0.58. This because I think you can remember the ReLU function. It converges all the minus marks to 0. So here it is 0. Here it is 0.559, which means it's 0. And here it's 0.25, which means it's 0.25. Likewise, we can calculate these filters, this map also. So here it is 0, here again it's 0, and here it is also 0, here it's 0.82. Likewise, we can calculate all the 16 values lies here. And after that, we are going to apply max pooling. So max pooling means, since we are using 2x2 filter size here, we are going to get the maximum value out of these 4 values. And since it is 0.58000, the maximum value is 0.558. It is 0.58. Likewise, you can calculate all the maximum values and get the max pool layer output here, right? So that is how we are going to calculate this maximum, this part. And as I said earlier, you don't need to do these things by yourself, because there are libraries that we are going to use tomorrow to do this all, to do all these tasks for us. So we do not need to worry about these mathematics. You need to know these things because you have to get a clear image in your mind what is happening around these things. I hope you get the you got the idea. Yeah. So so what is happening? So what is the thing that is actually happening in convolutional neural networks? As I said, if the input numbers are small ones, then it is completely fine, okay to use these kind of neural networks. But the thing is, when it comes to images, let's say it is let's say it is 125 times 125 image. So these are some big images, right? So we have to grab and select the features that we need to input to our neural network. So this part is the feature extraction part. And this part is our general training part. So as I explained earlier, what is happening here is we input our images from this side and we get our desired output. So here, this is a handwritten digit identifier. When you input the handwritten digit 4, it should fire the 4th one here. So if it is not the case, there should be a loss, which can be calculated using the loss function. That then you are going to find new weight values for all these connections. But since now this is a convolutional neural network, not only these weights values will be the ones that are going to updated here, but the filter values also. You might wonder, we know these values, but what is the use of these? Where can we find numbers to fill out these filters? So this is as in this case, the W's are the things that is going to be initialized as random. Here the filter values are the random ones that is going to be assigned here. And here also there is a bias. We can add the bias to this instance also, these filters also. So I think now you have got the idea. We input the images and there may be some random values initialized to the filters, and we can easily calculate the max pooling values. And then we are going to flatten our max pooling outputs, and then we are going to proceed these input data to the end by using these random weights, which are not the perfectly aligned ones which are with our target, with our task. And then there may, since these weights and the filter values are completely random ones, then there might be a big loss. So then, as I explained earlier, we are going to calculate the loss. We are going to differentiate this loss with respect to those weights, and we are going to back propagate this loss to the front, not only to these weights but also to the filter values also. So that is what is happening in this convolutional neural networks. As I know I have said this sentence around 10 times. Do not get confused with the mathematics. You should definitely know how it works with the mathematics, but to do our project, it will be okay. First, I feel that after doing this project, you will be able to know what is happening, what is the intuition behind all these things, and and the mathematics that I have taught you will make sense to you. So it is don't worry if you did not understand any of these things, because you might understand these things once we do our project. So that is my belief. So tomorrow what we are going to plan is to build this convolutional neural network. And please don't think that it will also be a big task. Actually, it is also some 9 to 10 line code to do this, to create this architecture, and we are going to train it, and we are going to build our model, and we are going to test our model using some testing data. So that is the way that we are going to do. I think we have come to the end of the session for today. So if you guys have any questions, please ask. And as I said, I am also machine learning enthusiast. and I have worked around around 24-25 months in this field. So, and I am still also learning these things. So if you guys have any questions, I will be able to help you with my knowledge that I have gained throughout these years. And as I said, we have targeted the undergraduates who are struggling right now to do their final year projects with the machine, which have been selected under machine learning and AI categories. So I hope that this session will lighten up their machine learning knowledge and how to understand a project. And so, and with the tomorrow's session, we are going to build a image classifier using Python from scratch. So I hope you guys will find it more useful than this first session. But in order to understand the concepts for the coding part, I strongly recommend that you need to know about these things. That is why we have given the theory session also. So I hope, Primash, I think you have to get the control now. Hello?
Yes. So now it's time to clarify your doubts on today's session. Feel free to type in your questions in the Zoom chat or in Facebook comment section. Please make sure to select everyone category instead of host when you're typing your questions in the Zoom chat.
Yeah, I get the first question here. Dilshan Muthukuda asked, Aya, how do we choose the layer size for hidden layers? Yeah, yeah. Let me tell you a small story. In machine learning and deep learning, there will not be a single expert who can build this architecture in one run. Actually finding this number of layers that we need to add our architecture to do our task is a trial and error thing, because we have to if you have a good knowledge on machine learning stuff and you have great experience in this area, definitely you will be able to identify you will be able to shoot with a great goal, to shoot with some great parameters here. We call that hyperparameters. But still there will but still there may be some accuracy gaining methods that we can use, which we have to do using some training methods. By training methods, we can let's say we are going to train our neural network by having five layers. So if the accuracy is not going to be a great one, then we are going to do some changes in the architecture. Let's say if the accuracy is not good, then you are going to add many some two other layers to your neural network. So likewise, you have to find these the number of layers, the layer sizes by training the neural network. That is what you have identified. That is what I have experienced in this area. So Chamwad asked, can you explain again the difference between test data and validation datasets? Yes. As I said, yeah, let's think that you are going to run a big network. Let's say that you are going to use around 15,000 images as your training dataset, and you are going to train your network. And if you are not going to use a GPU, it will be a very long process, right? You will have to wait, let's say 2 or 3 days in order to complete your training process. But just imagine when you open your computer after 3 days and you see that your accuracy is around 0.2 or let's say 20%. If there is a way that you can identify that your model is not going to perform well at the day one, then it will be a big benefit to yourself, right? So that is what is doing by this validation accuracy. When we train our network, there are basically two accuracies. First one is the training accuracy. The next one is the validation accuracy. The validation accuracy is how our network performs to new data, which it has not been trained yet. The thing is, we use test data at the end of the complete process once our complete model is done. But we can use validation data sets epochs by epochs. So once we train our entire network for epoch 1, then we can use a validation data set to get the accuracy and to get an idea about the way that our model is training. So if we can see that our network's accuracy, network's validation accuracy converges around 40%, that we are going to then that we definitely know that then our machine learning algorithm is not going to perform well, right? So then you don't need to wait until the 3 days to complete your process. You can just kill the process, and you can change your hyperparameters. You can rerun your training process. So that is the basic idea of using a validation dataset. Yeah, another question: is it possible to implement parallel networks in the same model? Yeah, you can say, yeah, in Keras there are 2 types of models that we can using in Keras. First one is the sequential model, and other using a sequential API, and the other one is the functional API. We use this functional API to do some parallel tasks. Actually, in my undergraduate life also, I have created a parallel neural network that you actually in my undergraduate year, undergraduate project, FYP, I have input human face. Then it is going to be categorized in the under 3. It is going to give 3 outputs. So it has been done under this parallel running 3 networks at the same time, using adding some branches to the main branch. So that is a bit complex than the original one. You need to have a good idea about this functional API. So basically, we are going to perform sequential we are going to perform our task using sequential API tomorrow, but I will be able to give you an idea about the functional API also. So yeah, these are the 2 questions I got so far, and since time 7:10, I will be able to answer one other question if you have in your mind one. Otherwise, we will wrap up the session for today, and we will do our coding part tomorrow.
Yes, and I have a quick announcement. We have put up the link to the feedback form. Make sure to fill it today, as well as the form link we put up tomorrow as well, because only those who fill it on both days will be receiving the certificate of participation. And make sure to provide the name you want in your certificate in this feedback form. Keep in mind that the link for the feedback form will be closing within an hour.
Okay, this is the last question that I think I will have to answer. Is it actually possible to do machine learning without solid understanding on mathematical stuff behind ML algorithms? Is it meaningful to use TensorFlow-like library without mathematics? No, definitely no. You have to have the idea about the mathematics around these machine learning things to go a big journey. Because if you are not going to perform, if you are not going to understand these mathematical things that lies around these libraries, then actually I cannot recommend that thing, because your journey in this AI stream will not be a long one. You definitely should you should have a great knowledge and clear understanding about these concepts and the mathematical basics and how mathematical concepts interact with those libraries and the concepts to go a very good journey in this AI stuff. The thing that I have said is to do the project, you don't need to have that much of a mathematical idea, because it is a one-run thing. But if you need to dig deep in these sessions, and if you need to dig deep in this AI stream, then you should definitely have a clear mathematical interpretation for the things that you are going to use by your libraries. That's the way that you can go through all this stuff and be a good machine learning engineer or AI engineer. what is the best platform between TensorFlow and PyTorch? Personally, I use TensorFlow and Keras because for me it's easy, but I don't know about this thing, but most of my colleagues say that PyTorch is used for most research type things, but I'm not quite sure about that thing. I also have used PyTorch PyTorch to create my ML algorithms, these deep learning algorithms, but the most work that I have done is using the Keras with TensorFlow. What are the mathematical concepts for coding? What are the mathematical concepts for coding? Actually, to do the coding, you need to understand each and everything that I have taught you today. But the thing is, since you are beginners, I know that these things will not be able to. These things will be bit difficult to understand in one run. But I think I can give you some good links that you can follow up, which gives this mathematical knowledge on this ML-based coding stuff, and to gain the idea and to gain the basic concept of these things. So so tomorrow I think I will be able to share those links with you guys. So then it will not be a problem for you. So I think that is it. This is it. So control over your side.
Okay. I think everyone managed to clarify their doubts. Before winding up the session for today, I would like to invite the Secretary of IET on campus, University of Peradeniya, Ms. Hansika Gajanayaka, to deliver the vote of thanks.
Good evening, everyone. On behalf of the members of the IET on campus, University of Peradeniya, I would be glad to extend a very hearty vote of thanks to our guest speaker of the event, Engineer Mr. Sahanika Veeraratna, for taking the time out of his busy schedule to conduct this session today. I'm so grateful for the effort and time you took to share your knowledge, experiences with us. Also, I would like to extend my thanks to the participants for your time and unwavering attention throughout this session. I'm confident that you have learned a lot of things today. It would be grateful if you could fill the feedback form as well. My special thanks to our senior treasurer, Dr. Sudhir Navaratna, for always supporting and being with us. My grateful thanks also go out to the members of the organizing committee who made this session a wonderful and successful event. Hope to see you all tomorrow at 5:30 with our second session on Eyes on AI. Thank you very much and good night.
Okay, with that, we have come to the end of the first session of Eyes on AI. Hope that all of you gained a good insight into the world of AI. Use the same link to join the session tomorrow as well. Thank you for joining with us today and hope to see you all for tomorrow's session as well. Have a good night.